So we know that in order to upload program, we need to go to Arduino environment. So here, and this is the default Arduino environment. And if I want to introduce with you, so this first one, tick symbol, it is the verify or compile. So using this, we generally compile our code, compile our use case. And the next one is the upload. So this upload function that we are not dealing with right now since we are simulating it. So when we do this sort of projects or other things in physical environment, then we generally connect our Arduino board through USB in our PC, and then we tick this one, we click on this one, upload, so that the program is uploaded to the Arduino board. And in Arduino board there is memory, so obviously you don't need to connect it all the time with the PC. You just disconnect it and the Arduino board will be operational as per the program. And this one, the new, so this is just like a new use case. So you are creating a new use case and this one open. So if you want to open previous use case, and the last one was the save. So if you want to save your current use case, so obviously you need to click on this. And this other setting are also, yes, this example one. So there are many examples related to many areas. For example, previously I show you the basics. Through these basics, I show you the blink code. So for example, you just bought an display, let's say, and you don't not display, let's say. So you don't know what is the basic program or would be the architecture of the program. That is this one, liquid crystal. So LCD display, what we call LCD, that is mean liquid crystal display. So here the default code or an example code is already given. So you just can try this one, and if you find something helpful, then you can write more lines within the code. So that's why these examples are so helpful. There are different, for example, this servo motor, stepper, or many examples are here. So this thing is important. And other things are just like any normal software, like through this edit you can cut, copy, paste, or indentation, commenting, uncommenting in the C program. Anyway, and this one is just like these functionalities like verify, upload, and other things. And another important thing is here, this board. So when, for example, you are performing your project with Arduino Uno board, so when you write your program and you are going to upload, then obviously you need to select this Arduino Uno. And if you want to work with Arduino Nano, that means if your board is Arduino Nano, then obviously you need to select this one, Arduino Nano, and then you will write the necessary codes and compile and then upload. So obviously this should be similar with your board. Since we are working with Arduino Uno, so Arduino Uno, which is the default one, is selected. And second one is the COM port. So this is the communication port. So when you connect your Arduino through USB, it is actually connected to a communication port. You can find the communication port from device manager. So when you use the Arduino board in real life, then generally you select different COM ports. There could be many COM ports like COM1, COM8, COM9, and you need to first see which COM port is using that Arduino. It is obviously seen from here, device manager. Here, this device manager. Through device manager, you can observe which port is using that Arduino board, and you generally need to select that COM port, otherwise your program won't be uploaded. So that's why this is an important thing. Okay, and if you ask me how can you improve your coding skill, especially the Arduino coding skill, I obviously recommend you a good site that is actually the Arduino's. So arduino.cc, then references, yes, this one. Now, so first of all, we can create a new project. So new project, new, so new use case is created. Our first program, if you remember, so we have in our void setup, we have pin mode, and I recommend you to write code in yourself. Don't copy code from anything. If you copy code, then obviously your skill won't be improved. So always it is the best choice to write code yourself. That's why in the lab sheet I didn't write or I didn't copy paste the code from the editor to here. I give it as a screenshot so that you can copy, and I obviously recommend you don't copy anything from internet or any source. Always write code. You may write exactly the same code, but I recommend you write it, don't copy. So pin mode, this is 13. I want to use that output. So this was the void setup, and in void loop we have a digital write 13. Initially we have make it high, that is the powering one. Then we have a delay of 1000 millisecond. Then we have another digital write having a low signal at 13, and then we have a delay of same same 1000 millisecond. Now I can compile it here, verify. So okay, I need to save it. So I'm going to save it here, documents, then our lab one, and let's put it lab one code save. So now after saving, automatically it asks to save. Now it is compiling as mentioned. So now it will give me a hex file, and I will mention the hex file in our Proteus, just like our previous video, as I mentioned in initial video. Okay, meanwhile, I may show you the web page. So here, the language reference. So this digital write, digital read, anything you can learn from here. For example, I want to learn more about digital read. So I just clicked on digital read, many things here. So you just read. So it basically reads the value from a specified digital pin, and the value is either high or low. So if you read from this, obviously you will find the original information and also the precise and correct, and all the information are here, all function reference are here. So obviously this is a good source. Also the example, some example codes, any warning or anything that they want to describe, all are here. So this is a good source, good resource to learn Arduino programming. There could be other good resource also. I just found it, and since it is the original, web page of the provider, that is the Arduino, so this is a more solid information source. So you may read from this. So okay, so it is done compiling. So all I need to now copy this hex file location. So this one, Control C, then within Proteus, I need to double click this one here, Control V. Okay. So now I need to perform this one, that is the run the simulation. So run the simulation. Okay, so now it is running. Okay, I didn't mention how can you choose to vary this R1. So just double click and there 1K. So I'm just writing is 220 R. That means it will take 220 ohm. Yes, now this is operational. So yes, so the LED is blinking now. Okay. Yes, it is high now for 1000 millisecond, and now it is low for 1000 millisecond, again high. So LED is blinking. So I just describe our initial this one, task one. Now the second task, for this I need to integrate this potentiometer. So I just stop the simulation, and now I will add the potentiometer here. So from component mode, I already took the potentiometer, pot AZ, just single clicked it, and here put it here, let's say. Okay, so for potentiometer, I need a voltage source and a ground also. So I can found it from the terminal mode. So this ground, single clicked, then here, single clicked, then this is basically a 5 volt DC source. So I can choose this one, power and power. You can also choose power from this generator, this DC, and you can mention it is as 5 volt. Anyway, anything will work. Now I need to connect wires. So single click here, then single click here, single mouse click here and here, and I want to connect it with A0, let's say. And I need to integrate the sense in our code. So here, so now I want to use a sensor value function. So integer sensor value, let's say initially is at 0, 0, and I am using A0 as the input. So pin mode A0 as input. And within the code I actually first read the value. So sensor value is equal to analog read A0. We are reading the value at A0, and then whatever it is read, it has read, I want to write it in delay function. So sensor value. Similarly here, sensor value. So code is completed. I just saved it, Control S, and now I am again verifying it. That is, it will compiling now. Okay, an error occurred. Oh, sorry, I just give it a mistake. It is a small a. So now verify. So done compiling. So I can choose this hex file, and it is better to copy it again and paste it, but okay, this hex file didn't change actually. So it is not a problem. So I may just, just run it again, because it is automatically the same hex file. The hex file didn't change since I didn't change the program name, and I didn't choose a new case or anything. So the hex file location didn't change. That's why I didn't uh, give the hex file code here. Anyway, so let's watch the operation. Okay, I think I need to zoom out. Okay, so here if you click, so initially it is 50%. I think, okay, I think it is not visible. Let me, okay, let me first stop the simulation. Okay, now zoom in. Okay, so I think now it is quite visible. That is 50% it is now. So I am running the simulation again. Now it is 50%, so let's put it to here, that is almost 9%. So now you notice that it is blinking so fast. Why so fast? Because this potentiometer value, I have chosen it as a smaller value. Since the value is smaller, so the delay value is smaller. So delay value is smaller means the frequency increased. That means delay is smaller now. And if I choose at 100%, let's say, so it will, okay. Notice it will turn on for a longer period of time. Now turned off for a longer period of time. So I'm controlling the frequency of the LED using this potentiometer. So if I choose here, so this is more of a normal operation, and if I choose here, so it will be a faster operation. So I think demonstrated our second experiment. So if you have any question, feel free to ask me, feel free to reach me through email, through comments in Google Classroom or anything. So I'm stopping here. Thank you. Bye bye.